In this series of episodes, we'll be making a robot with 4 legs that moves like a dog. We'll be designing the skeleton of the dog, we will be writing the firmware, designing the electronics, and possibly adding sensors and behavior. But we can't do all of that in one episode. So in this episode, I'd like to focus on just designing the skeleton. One decision we have to make before designing is muscle. We will be using servos like this one. It's a medium hobby servo, and we're going to be using a wheel on the drive shaft like this. So why don't we take this servo with us and move over to the computer and start the design process for the skeleton. Okay, so let's start by opening up OpenSCad. It was written by Clifford. I like using OpenSCad as opposed to other modeling programs because I like to write code. I'd rather write code than use the mouse. So let's start by making a parameters file. And the first thing we're going to be doing is designing a servo. So let's start by putting all of the variables in that we need to know about the servo in order to model it. We're going to need width, depth, and height of different attributes of the servo, of how the servo connects. So let's get these 3 variables going, and I measured these attributes of the servo with calipers, which I think are much more accurate than other methods of measuring. We're also going to need to know drive shaft attributes, so the radius of the drive shaft, as well as the radius of the screw hole that goes into the drive shaft. We're also going to need to know the radius and height of the disc, or the wheel that attaches to the drive shaft. And with these variables, we can directly use them in the next file that we're going to make, which is going to be the servo file. So let's save this and let's make a servo file. Okay, and you're going to see that modeling with OpenSCad is pretty simple when you get started. So let's include the parameters file that we just wrote. And now we have access to all of those parameters or variables. Let's start by unioning what we're drawing here. So we're first going to make a cube inside the union, which will be union to any other cubes or cylinders that we make. So we know the dimensions of the cube because we already measured the servo and we have those variables. We're going to center it, and let's see how that draws. Okay, very cool. So now let's make another one using the second set of parameters. I did that wrong. Let me think. The height is wrong. There we go. Okay. But now it's located in the wrong place. Everything's centered, so we need to change its location. So let's assume we're going to translate everything, translate or move everything. And let's start by moving it nowhere, and then let's move it, let me think, height 2, no, height 1, there we go. Okay, so now it's starting to look like the servo that we have. And let's also make the drive shaft. So we're going to use a cylinder for the drive shaft. And we know the dimensions. We have the radius, and we have the height. Actually, we don't have the height. Let's call it the depth of the drive shaft, I think. Okay, there we go. Okay, so now we can use that. And let's center it as well. And let's see how that renders. So right now it's not rendering because it's actually inside the cube, so we can't see it. So we need to move it the full height plus half the height of the cylinder. And you see the sides, there's only like, what, 12 sides to that cylinder, so it looks low resolution. So let's increase the resolution to 100. And now there's 100 sides on that cylinder, and it looks much more like a cylinder. Okay, now instead of moving the cylinder over to where it needs to be, we're going to move the cubes that make up the body of the servo over. And so now the drive shaft is in the center of the z-axis. Now let's make this even more complex by throwing all the code in a module. A module is like a function, and calling it servo. So now nothing draws because all the code is in a module. But if we type servo, we got a servo. So very cool how something complex is now very simple. We just type servo. So now let's make a leg file. And with this leg file, we not only have our parameters, so let's include our parameters, but we also have our servo. So let's include servo. And a servo is immediately drawn, which is not what we want. So let's take out servo. Okay, and now let's use servo in leg. Perfect. So it's drawn when we tell it to be drawn. And we can demonstrate that we can draw more than one. So let's translate one servo. Let's translate it 50 millimeters in the Y direction. And so now we have two servos drawn in different locations. All right. So I'm not going to bore you guys by typing out all of the code needed to make this bot. Let's paste in the code that I've already written for leg. And the only thing different about the leg that we haven't done in the servo and making the servo is we use the difference operator, which subtracts one object from another. And that's really the only function that we haven't already used. So there's no need in walking through all of this. Let's try to draw a leg upper, or the upper leg. No dice. Yes, we need more parameters. And let's simplify some of these parameters, shorten them a little bit. Servo box width, servo width, depth. And then that looks good, I think. Okay. Let's try again. Save. Save. Okay. So this is the upper leg, and we see it attaches two servos together. And we'll see a little bit better later on. And then this is leg lower, or the lower leg, which will attach to the disc of one of the servos. Very cool stuff, and very simple. These functions are only 10 to 20 lines long. Servo disconnector. We'll use that in the shoulder, old code. We're not using that object. We're using, for the shoulder, we're using two connectors. We're using this function. So we see that connects two discs or wheels together. So now we have a leg, or at least all the objects that we need for a leg. So let's pull in three files: the body, the metric fasteners, and drawn together. And drawn together is exactly what it says it is. It just draws the body and the four legs and the servos that we need to make it all work. So we're pretty much done with the CAD aspect of this robot. But let's just see it move. Let's turn on animate, and let's go to 16 frames per second, 20, actually 4 steps. Let's go 4 steps because that's how I coded it. Okay, so this is the turn sequence, and it's kind of boring, so let's comment it out and turn on the walk sequence. Very cool. So this is still, we're all virtual. We're still designing this robot, and we can see it walk in a virtual environment. I love OpenSCad. Very cool. So that's it. That's our CAD work. Keep an eye out for the next episode, where we'll be taking one more step into turning this virtual robot into a reality.